Alright, so here is where completing a square is very useful, where you actually might want to complete the square. I know that in the previous problem, sometimes given the option, you would not choose completing the square. It's not always the easiest option to pick from, and it doesn't always work out. But with rewriting the equation to vertex form, we are going to want to complete the square. And we're going to see this in this chapter as well as in chapter 9, and I think in chapter 5 again. We're going to see it a lot, and you're going to see it in pre-cal as well. So I'm going to write vertex form over here because we want to go to vertex form, so we need to know what that looks like. That looks like this. A parentheses x minus h squared plus k. Remember that h and k was our vertex, so that's why this is called vertex form. You can see the vertex just when you look at it. A is the stretch. It also tells you if there's a flip on it. So we want to make it look like that. This part of it is why we know we want to do completing the square. We want to factor this in some way that makes this perfect matching binomials that will make that squared portion of the equation. This is even easier than the solving, I promise you. It's like half of the process only. So like I was doing before, I'm looking at this equation. The only difference is that I don't have a 0 on the right, on one of the sides. I have a y. So what I'm going to do is, I don't even know if 22 is a good number. I don't even care. It'll work regardless. I'm going to get rid of the 22. So what I'm going to do, always that works, is just get rid of this number. We're going to subtract the 22 from both sides. So that on the left side, I'm going to have y minus 22. And don't forget, we're completing the square here, so we need to leave a little bit of room for our magic number. On the right side, x squared minus 10x, and then my magic number. So what is a little bit weird is that the left side is different, you know, and my factoring is on the right side. Hopefully that won't bother you. So we're going to factor the right side. We're going to make our perfect factors that match, x and x. Half of negative 10 is how we decide our matching factors. Half of negative 10 is negative 5, because these factors need to add to negative 10. They also need to multiply to be the last number. So this is why we're deciding what number goes there to our magic number. Multiply these together. That number, the magic number, is 25. This way we have our matching binomials. And if that's on the right, it needs to also be on the left. So I'm just going to clean up the left side. Negative 22 plus 25 is positive 3, so the left side is y plus 3. The right side, I've got my two factors there, my two binomials. I know that I want my two binomials to be together with a squared outside, so I need to clean that up and just rewrite x minus 5 parentheses squared. Because we're smart, and that's how you write it when they're matching. On the left, y plus 3. And there's only one more step to that. Subtract the 3 to get the y alone. It'll just go on the end. So it'll be y equals x minus 5 parentheses squared minus 3. From this, we can tell what the vertex is. I'm going to go ahead and write that. It's going to really ask you for that. But it's important to realize how easy it is to tell from this. HK is the vertex. So remember that the formula always has minus on the H in the formula. So we're changing the sign on this because it's supposed to be minus. So H is 5, that's my x value. And then negative 3 is my y value. Remember in Unit 1 we talked about this as far as movement. The negative 3 moves it down 3. This negative 5 moves it right 5. That's why it's a positive 5 and a negative 3. This is the vertex. You can also tell, looking out front, there's no stretch. There's no negative. So it opens upward, kind of a U shape. And the vertex is at 5, negative 3. So we can tell that it's going to start below the x-axis, and we know it's going to go through it twice because it starts below it. So we can tell a lot of things from just looking at that vertex form. All right. The second one here, the only difference is that 2 out in front. So it's going to make it a little bit different on the work. We've got to factor the 2 out for part of the process. So working it out again, I'm going to make it be into vertex format, and again, I'm going to get rid of the 25. I'm going to move the 25 over with the y. So it's going to be y minus 25 on the left, and then I remember I need to put a plus something there And if you forget, you can always put like plus box over the top or something. And then 2x squared plus 24x plus our magic number. And remember, we don't know what it is yet, but we know we're completing a square to do this. We know we're going to have to put something there to make it work out. Again, we've got that 2 causing us problems. So we're going to factor the 2 out, just like we did with the 3 on the solving problem a few minutes ago. So factoring the 2 out gives me x squared in front. Remember that you have to divide the 24 by 2, so that's the middle term is 12x. And remember that the magic number is also being divided by 2. So we have to work our way back to that by using the 2. And then minus 25 and then plus our unknown. Okay. So now we're going to factor and see what we get. So 2 is still out front. And x and x, what's half of 12? 6. So plus 6 and plus 6. That's always half of that value. So 6 times 6 is going to tell me what really goes in this box, and that's 36. But remember that that's not what I put on the left side, because it's in the parentheses. The 2 needs to be applied to that 36. So 36 times 2 is 72. So the magic number is really 72. Okay. So on the left side, 72 minus 25. Somebody help me out with that. What is it? 47, thank you. Plus 47. I thought so, but I didn't want to mess that up and then mess up the rest of the problem. Okay? So we've got this 2. It's still there. That's my stretch. In my vertex form, 2 is going to be out front. It's going to tell me I have a vertical stretch of 2. My binomials need to be written as one thing. This tells me my movement, tells me my x value of my vertex, tells me it's got a shift of negative 6, meaning left 6. And I'm almost done with it. Okay. I just need to move that 47 to the right side so I can tell about the up-down shift on the equation. So y equals 2x plus 6 parentheses squared minus 47. So I can tell that this equation has a stretch of 2, a positive 2, so it's not flipped. It has a vertex of negative 6, negative 47, meaning it's going to be moved left 6 and down 47 from the parent function. And so this equation tells us a whole lot about it. If we want to get the vertex from the equation, remember it's the x value is always the opposite sign, and the y value keeps its sign based on the formula being an x minus h and then plus k. That's why you change one of them, but you keep the other. So this is the vertex. I don't think it asked me for that, but if I were to graph it, I would need to know that. So I know I have a stretch of 2. Here's my vertex, tells me to shift on it. I can tell my axis of symmetry if I wanted from that. Axis of symmetry is always x equals, and it's always the x value of the vertex. Okay, so a lot of things can be taken from that. I probably wouldn't make you graph that by hand, being a negative 47 on the y value. It's not really going to fit very well. But we could if we were having to.